Good afternoon and welcome everyone to this session. Use RAG to improve responses in generative AI application. This session is a level 300 session and today you'll learn more about building generative AI applications in a well-architected manner and how to improve the response in your Gen AI application. It's my pleasure to welcome on stage Chiedu Eluehike and Dr. Sam Mokhtari. Please give them a big round of applause.
Hello, everyone. Hello, everyone, and welcome to this AWS Sydney Summit session titled Use RAG to Improve Responses in Generative AI Application. My name is Chiedu Eluehike, and I'm a solutions architect at AWS. In my role, I help customers to translate business problems to technology solution. I'm very excited today to be co-presenting with my co-speaker, Sam. Sam, do you want to introduce yourself?
For sure. Hi everyone, my name is Sam and I'm also an Accelerate Compute Specialist with AWS. And my focus is actually more on helping customers to optimize their AI infrastructure. Very excited to be here.
Awesome, thanks for that, Sam. So before we dive right in, please note that this is a level 300 session. And so we assume that you have a foundational knowledge of generative AI, large language models, LLMs in AWS Cloud. So in terms of agenda, this is what we're going to talk about today. First of all, we're going to talk about the limitations in large language models, LLMs. We are then going to talk about current approaches to improve the responses in generative AI application. After that, I'm going to pass over to Sam, who is going to go deep into the RAG architecture patterns and best practices that you should consider today. And then finally, I'm going to do a demonstration of building RAG applications and using Amazon Bedrock and applied to an enterprise use case. So let's start. Today, generative AI is making significant impact on our customers with improvements from customer service to insightful financial research and more. The underlying large language models, however, have certain limitations. And I'm going to talk about the three most common ones we see. The first is LLMs can generate plausible sounding but inaccurate response. Today we all call this hallucination. The second is LLMs are trained on vast amount of static data. So this means that they don't have access to recent data in your company's enterprise. And the third is that large language models, LLMs, often lack specialized expertise in specific industry domains and use cases. Now, all of this introduces regulatory risk and brand reputation damage to customers. And this means that we need to solve for this. Now, in terms of solving for the limitations that I showed in the previous slide, we speak to customers on 4 approaches and we tell them to evaluate this based on the complexity, the quality, the cost, and the time to implement. The first is prompt engineering. And with prompt engineering, this is basically the practice of taking a piece of text and using it to guide your model towards a more accurate response. The second is RAG, and RAG stands for Retrieval Augmented Generation. And this is basically a way of extending the model's capability to your organization's internal knowledge source. And this is going to be the focus of today's session, and it's where we see lots of customers get benefits from their Gen AI applications to improve response. The third is fine-tuning, and this is the process where you take a pre-trained foundation model and you adapt it to a specific use case or task. And then last but not the least is training a foundation model from scratch. And this is the most complex and time-intensive approach to improving responses. Again, we're going to focus on RAG today. So let's dive right into it. What exactly is Retrieval Augmented Generation, RAG? Now, this is an architecture pattern that's simple but yet powerful. And basically, you have a user that asks a question. The system then retrieves relevant information from your company's knowledge base, which is retrieval. Then the response from that is then added to the user's query, and then the response is fed in as an additional context. And then lastly, the augmented query is then sent to the foundation model, and then the response is generated. Now, in terms of how this works in terms of the end-to-end flow, we can break down RAG into 2 particular parts. Now, the first is the data ingestion workflow. And what happens here is that you connect your data source in your company. So this could be your SharePoint site or your S3 bucket or wherever it is that you're storing your documents. The document is ingested and broken into chunks. And my colleague Sam is going to talk about the different approaches to doing that later on. It's then fed through what we call an embedding models. And basically, this is a process where you translate text into vector, which is what machine learning systems understand. Then that vector is then stored in what's known as a vector database. Then we go on to the second aspect of the RAG workflow. Now, a user then sends in a query to the system. That then is used to retrieve information based on the closest similarity search in the vector database. And then the context that's gotten from that is then added to the query. It's then augmented into the query, and then it's passed on to the large language models. And then you have your response generated. Now, all of these steps and process, we built Amazon Bedrock as a service to help with the heavy lifting. So Amazon Bedrock is a fully managed service that offers a choice of high-performance foundation models for you through the use of a single API. Bedrock is also serverless, which means that you don't have to manage any infrastructure. And last but not the least, Bedrock has Bedrock Knowledge Base, which is our managed RAG offering that handles all of the heavy lifting in the previous step that you saw previously. Now, to go deep into the RAG architecture patterns and best practice, I'm going to hand over to my colleague, Sam. Sam?
Thanks, Chiedu. All right, so now what I'm going to cover is just the key architecture pattern that we have on AWS and also some of the best practices that we can apply to make those RAG responses high quality. Let's start with the first one. So my colleague already talked about this workflow, which is the text generation workflow, which is the main part of the RAG. We have some customers that whether they wanted to have more control, whether on the infrastructure or whether on the model behavior, or sometimes the compliance requires them to just make their solution to be in a very self-managed way. So for that, this is the first pattern, and we there are three key components that you can see. We have like the embedding model, the vector database, and also the LLM. So those are like the key component that we need to have like some compute power to just support that. So for the purpose of vector database, we usually have like CPU-based instances. And a very good option on AWS is to just use AWS Graviton, which is the purpose-built ARM-based chip. And we have like EC2 instances that are powered by those that can provide up to 40% better price performance compared to comparable x86 EC2. For the model, whether it's LLM or embedding, we have like the AWS Inferentia, which actually provide up to 2.3 x better throughput and also up to 70% lower cost. And these are like the options that can be used to just run the whole RAG system, whether through the EC2 instances, or if you are trying to just run it through the container, then you can just leverage EKS and through the Carpenter to just run the whole RAG system in a self-managed way. So that's the first pattern. The second pattern, as my colleague already talked about the Bedrock, so you can just run your whole RAG system in a very fully managed way, and then it's just Bedrock, as my colleague already talked, it's just API based, right? So you have like this retrieve and generate API that you can leverage, and then you can just run the whole RAG system and just abstract the whole infrastructure, and then it's just going to be running the RAG system in a very fully managed way. For sure, you don't have like a lot of flexibility if you want to make the customization, but this is for the teams that they want to just make it more like a kind of manager style of RAG system on AWS. And then the third pattern, it actually is still you're running in a managed way, so you don't need to be worried about the infrastructure, but then you have some flexibility in terms of like doing the context management or doing the proper prompting so that you can have like this retrieve API, which actually you can leverage to just retrieve the relevant document for your RAG system, and then you are responsible to take care of all those context management or the prompt augmentation that is required. And that's actually the pattern that you have some more flexibility to just do more optimization and improve the quality of response. And that's going to be like some things that I'm going to just leverage to just talk about all those best practices that we're going to cover today. But before we jump onto the best practices, let's just understand what is the high quality response for the RAG system. So there are like some key principles that you need to consider if you want to run RAG your system, including high quality responses. The very first one is just the precision. You need to make sure that you have like an accurate retrieval from the relevant information and then generate a more like a precise response through the whole RAG system. Also, you need to make sure the response that the LLM is generated is relevant to those retrieved document that you have it in the whether in your vector database or knowledge base. So, and then the third one is just efficiency. You need to make sure like whatever response that you are generating, it actually comes with like a lower cost, because cost is going to be like a very important aspect, especially for all these generative AI use cases. Reliability is another thing. So if you start to scale your vector database, or you start to just have more types of query, then you need to have like a consistent performance at the scale. And then the last one is governance. You need to make sure like you are addressing all those compliance, security, all those key requirements that you have for your AI use cases. Also, my colleague already talked about this workflow. To make it easier to understand the key best practices, what I did, I just include 4 key component of workflow out of this whole architecture. So we have the vector database hydration or knowledge-based hydration workflow. Then we have the retrieval part. We have the LLM integration, which is more around the prompt augmentation and all those things that you do for the context engineering. And then you have like the last component, which is more around the response generation. So what I did, I actually just classify all those best practices under these 4 categories so that you know what actually and where you need to apply that specific best practice. All right, let's start with the first workflow, which is the vector database hydration. So there are like some key like items that you need to consider here. First is the data quality. Whatever problem that you may have in your data source, if you don't manage it and if you don't improve the quality there, it's going to just cascade to the downstream workflow. And you need to consider this here as well. So the chunking strategy that you're going to use is going to impact the quality of the response that you're generating. Also, the embedding model, its configuration in parameters, is actually impacting a lot in the response that is generated by LLM. And you need to make sure that you have like more like a proper fine-tuning for your embedding model. And also, metadata, if it is relevant to those chunks that you are created, it actually can help you to improve the response of the whole RAG system. So based on this, the best practices, first things first, you need to just have like proper data validation before ingesting your data to the vector database. You need to do proper pre-processing and also making sure to address those data quality issues that you may encounter. Also, instead of just using chunking, which is like with the fixed size, you need to start to just do more like doing in more intelligent way. For the purpose of demo, we are actually just showcasing how actually intelligent chunking can help to improve the quality of the RAG system response. Also, to make your knowledge base and vector database current, it's good to just have a regular update for all the knowledge that you have. So you need to make sure that you establish refresh cycle for the vector database so that the knowledge is actually stay current. And also, if there is an option and you can just leverage the knowledge graph, it would be like a good option to just complement your vector database so that you can just help to improve the overall performance of your whole RAG system. So I'm just putting more like a kind of the architecture style of what we call it as a hybrid RAG, where you actually leverage both the vector database and also the knowledge graph. And then your retrieval use those information to generate the final response. So there was like a session that we had like today about the way that how Rio Tinto actually leverage this hybrid RAG. So definitely I would suggest if you are interested for this architecture pattern, when the session is available online, just check it out. The second one. So we already talked about the hydration for the vector database. Now for the retrieval, also one thing that you need to consider is just the query that the user that is actually just submitted to the RAG system. If you don't get the intent of the user properly, it's going to just impact the quality of the response. Also, the way that you actually just search the vector database or your knowledge graph is going to impact the output of your RAG system. So there is some consideration that that you need to have to make sure that you are using a proper search method as well for your retrieval. Also, the contextual awareness is another key important things that you need to consider, because whatever interaction that user had with your application, it's going to impact the quality of the response that the user is expecting. So that you need to make sure that that contextual awareness is also there for your RAG system to generate a high quality response. So in terms of the best practices, if you can, just leverage hybrid retrieval. So let's say if you are using vector database, you usually do like the semantic search for your vector database to get the retrieved document. If you can just complement it with the, like, let's say, keyword search, that's another option that can help you to improve the overall response. Also, query transformation is another key thing. So you shouldn't just submit the query or the intent of the user directly to the LLM. So I have like architecture pattern that is going to show how you need to just do the query transformation through what we call it as a multi-query pattern in the next slide. Also metadata, as I said, so if you have like that hybrid retrieval, so you can just add metadata to your chunk and to document, it actually also helps to improve the overall response. And then the retrieval parameters. So the thing is, you may just use like the similarity search or like the k-value. Those are the parameters that need to be fine-tuned to improve the overall performance of the RAG system. So the thing is, in terms of like the query transformation, this is one architecture pattern that would be beneficial to use. So instead of just directly submit the query of the user to your RAG system, what you can do is to just leverage a LLM to just convert that user query to multiple query, and then submit it through the embedded model and vector database, and then generate a number of search results to be used to just generate the context for your LLM. That's the kind of architecture pattern that shows how you can just do the query transformation to improve the overall response. The third workflow, which is more around the LLM integration, and the key focus here is more like around the prompt augmentation. So here, the context engineering matters, like the way that you structure the prompt is going to impact the overall response. Also, the instruction should be clear enough so that the LLM can generate the high quality response. And also the temperature of the model. So that's one of the key parameters that impact the quality of the response. And you need to have like a plan to control that. And the last but not least is all around the token economic. So the number of tokens that you use to just within your prompt is going to impact the overall cost of your RAG system and even the overall response of the RAG system. So that you need to also consider that to just make it in a more like optimal manner. So in terms of the best practices, so if you can just definitely plan to have like a prompt template so that you can strategically put the instruction, the context, and all those things in like a proper manner. In terms of the context management, so the thing is you're going to retrieve some document and then generate the prompt. So you need to plan in a way that provide the relevant information to the LLM. And so that context that you are building, you need to have a proper plan to just create that. So there is going to be like a kind of another architecture pattern that I'm going to cover, which is going to talk about that context management as well. Token optimization, as I said, the number of tokens is going to impact the cost and also the quality of response. So you need to optimize that. And then when you start to just have all those retrieved document or chunk or whatever, you need to have a mechanism in place to just remove those irrelevant chunk so that it can improve the context of your prompt, and also it can improve the overall quality of the response as well. So this is what so we already talked about the multi-query, but then if you can add it with what we call it as more re-ranking, it actually can help you to improve the overall response of the RAG system. So re-ranking, so let's say you have like the multi-query and just generate, let's say, up to 50 chunk as a search result, and you actually just retrieve 50 chunk out of those vector database. So if you can implement a re-ranking, which means just reordering the chunks that is going to be used to just create the context, and just put the more relevant kind of chunks on the top, and then remove the irrelevant one, that's how you actually just implement the re-ranking. There are like some methods that you can use, whether you can use the hybrid scoring or whether you can have another model to just help you to just do that re-ranking. And then with that, you actually just make that the context actually optimized to be submitted to LLM and generate the final response. All right, and the last one is just the response generation, the LLM, which actually just generate the response. So here, the key things that you consider is just to avoid the LLM to hallucinate and generate information which is irrelevant to those documents in your knowledge base. Also, if there is a possibility to just provide the citation and also attribution, that can help you to properly enable that explainability and transparency that you need for your overall solution. And also, you want to have like the whole solution to have like a proper consistency in terms of the tone and also the voice of the output. So you need to consider this response coherence for the whole solution. And the last but not least is the safety. So you need to make sure that the RAG is not going to generate harmful content or generating any information which is not relevant to your business and against compliance or any other requirement that you have. So in terms of the best practices, implementing guardrail, especially for the output, and then in AWS you have Amazon Bedrock guardrail that you can just leverage to just implement that, so that you can just do all those filtering and all those kind of like management that you need to have before generating the final response. Also, error handling is another key thing. So if the LLM doesn't have enough information to generate the response, it should acknowledge that. It shouldn't just hallucinate and just generate some irrelevant information. Also, at the end of the day, user is the person that needs to be happy with the output of the RAG application. So if you can implement the feedback loop, so you can get that feedback and start to just use it to just continuously improve the overall response. And then end-to-end evaluation. You need to just have a plan for just evaluate the whole RAG system end-to-end. And there are 4 key dimensions here that you need to consider to evaluate the overall response. So we have the retrieval performance, the way that you actually retrieve the document, the generation quality, which is actually the key, I would say, domain that you need to have a plan to evaluate. The user experience, as I said, user is at the end, user is the one that you need to be happy with the response, and you need to just evaluate the experience of the user. And the last but not least is the performance. You need to have like a proper low latency solution so that the user, it actually can impact the user experience as well. So on AWS, if you're leveraging Bedrock, there is like Bedrock RAG evaluation capability. So actually included a blog here through that QR code that it actually have all the details that you can leverage to evaluate your whole RAG solution from different perspectives, whether it's those 4 key domains that I covered, so that the RAG evaluation capability within Bedrock provide that options. But at the same time, if you want to have your own pipeline to evaluate the overall solution, you still have the option. Let's say if you want to evaluate your RAG system in terms of like the response of the RAG system in terms of like the semantic similarity. Let's say you have like a ground truth as an example here, and then you want to see which actually generated option is actually have a more semantic similarity. For this specific case, for sure, like the first one has so the ground truth is like Australia is a country surrounded by Indian and Pacific Ocean, and the first one is actually have like a higher semantic similarity. So you can just have your pipeline to get that ground truth. You can have like a evaluation data set built for yourself, and then use that evaluation data set to just evaluate the overall semantic similarity that is generated with your RAG system. So that's kind of like an option that you have full control on the evaluation pipeline that you have. And the same things can happen for the faithfulness. Let's say if you want to like evaluate the faithfulness of the solution, then there is the pipeline that you can just leverage, get the generated and retrieved document, and also the generated response, and then based on that, calculate the overall faithfulness of the whole solution. That's more like if you want to have more control on the evaluation pipeline. Awesome. With that, that's all from my side. And then I just pass it back to Chiedu to just talk about the demo and the use case.
Awesome. Thanks for that, Sam. Okay, so to practically demonstrate everything we've spoken about so far from my colleague and myself as well, we're going to just look at how to use RAG to improve the process of bid writing, which is a use case that we saw from customers. So just to, I guess, sort of convert the theory to practical. So what exactly is bid writing? This is the process of creating a formal proposal to win contracts, a project, or funding opportunity. And when we spoke to a lot of customers that build in this particular space, they told us that this was one particular use case. But also, this is for the demo purpose, but the application of RAG and knowledge base can be used for other purposes as well. Now, for bid writing, the process often involves the following steps. The customer identifies the right opportunity. Then they plan the bid writing, and then after that, they start to draft the response to the bid. So how exactly are they going to tackle that particular opportunity? And then after that, they send it to the internal review team. So this often involves like legal and finance and compliance to check that all the things are correctly, appropriately done. And then eventually the bid is then submitted. Now, in terms of this 5-step process, what we're going to do today is just have a look at the demo, and then also we heard from a lot of customers where the response draft is the aspect where they think that generative AI can apply a lot to. And again, this can apply to other use cases like finance services, healthcare, and the rest, but this is for us to demonstrate the knowledge base on Amazon Bedrock. So setting up Bedrock knowledge base is a simple 4-step process, and what this video is going to show you is what that looks like. So basically, you give your knowledge base a name, step 1. Step 2 is where you configure your data source. Now again, this could be your SharePoint document, it could be your Salesforce instance, it could be in your S3 buckets or any other knowledge base. And then you choose your chunking strategy, which I'm also going to show us a second demo about and which Sam spoke about. Then you select your embedding models. So this is what converts the text into vector to be stored. And then you select your vector store. Now by default, we use Amazon OpenSearch, but you can also bring your own enterprise vector database like Pinecone or Redis or MongoDB. And then eventually you create the knowledge base. Now this is the first demonstration that shows you how easy it is to create it. Now in the second demonstration, we're going to look at what happens when you create 2 knowledge bases. And on the left-hand side, you can see that we're using chunking, the default chunking strategy, which uses a fixed token size. On the right-hand side, we're going to chunk the document using semantic search, which is what creating the chunks based on the meanings of the word. Now, on the left-hand side, we have a bid writer here that asks a question, and they're asking for 2 fundamental things. The first is, what's the name of the safety system that Amazon uses? And give us examples of statistics where it's improved safety in the system before. Now, what you see on the left-hand side is that while with the default chunking, we can get the name of the safety stat, it's an ISO-based stat, we can't find the exact statistic, right? For this particular use case, I'm using default chunking. When we then use our knowledge base using semantic chunk to run that exact query with the exact data and company reports that has been stored in the same S3 buckets, we are now going to see a difference in the response when we use semantic chunk. Now, what we're going to see here is that the LLM, and in addition with the retrieval, is able to provide not just the ISO safety metric, that system that's used, it also shows us the exact instances where this has actually improved metrics in the past. So again, as Sam said, the choice of chunking strategy is very important in terms of the kind of responses that you get, right? And again, similar in terms of the demo, this is a simple 4-step process that you do in Amazon Bedrock. In terms of getting this to work. Okay, awesome. So we're just going to do a quick recap of everything we've spoken about so far. First of all, we had a look at the limitations of LLMs and then the ways that you can actually improve the responses in your generative AI application. Then we had a look at RAG concepts. And then we had a look at Amazon Bedrock Knowledge Base, which is our fully managed RAG service. After that, I passed it over to Sam, my colleague, who then went deep into the RAG architecture patterns and best practices for how you'd implement this today or for your application. And then finally, we did a demo of how you would set up Amazon Bedrock Knowledge Base, which is our fully managed RAG service to run this and to do this. Awesome. So thank you, everyone, for your time today. We hope you found the content useful. I would really appreciate if you could leave the survey, as it helps us to improve delivery. Have a good day and cheers.
Thank you. Thank you.